All right, so last time we talked about solving some basic equations, one-step, two-step equations. Today we're going to make them a little bit more complicated, but we'll develop some nice strategies to help us deal with that. So by the time we're done here, you should be able to solve a multi-step equation in one variable. We're going to deal with equations when variables are on both sides, and we're going to talk about what identities are, right? Equations that have infinitely many solutions or no solution at all, okay? So first things first, we're going to practice combining like terms, because that's what we're going to have to do a little bit of today. So your first three problems there are set up for you to go ahead and simplify. So go ahead and give those a shot, knock them out, and then start the video back up and see if you did them correctly. Okay, so how did you do? First one, you had to combine the 2x and the negative 5x to get negative 3x, and combine the negative 3 and positive 7 positive 3 and positive 7 to get 10. Second one, distribute that 3 to get negative 18c plus 27. Then combine the negative 18c and 5c to get negative 13c and the 27. You get the 27 plus 27. Okay? Third one here, distribute that negative 1. So remember that there's a negative 1 sitting out front of that parentheses. If you just see the minus sign there, right? So you get 6b minus 3b minus 8. Once you combine the 6b and the minus 3b, and you get 3b minus 8. Okay? Now, how does that pertain to here? Okay, so now, if you think back to last time, our strategy was there are 3 steps, right? So the first one is isolate the variable. In order to isolate the variable, you have to find the term that has the variable in it. Well, in this example, there's 2 terms that have the variable in it, this one and this one. And I can't solve for both of those m's. It doesn't make any sense. So before we get to our next step, which is undoing addition and subtraction, then the following step, which is undoing multiplication and division, we need to simplify first. Just like we were doing in our the first 3 examples, right? I need to treat this like there's a left-hand side of the equation. I can ignore the right-hand side for now if I wanted to. But there's nothing to simplify here. It's just a 5. Or I can ignore the left-hand side of the equation and try to simplify the right-hand side. So if I gave you that to simplify, you would want to combine the 5m and the 2m to get 7m, and then the negative 23 would just be sitting there. And then we can bring back in the left-hand side to make this equal to 5. Now you're set up. Now we can undo the subtraction that's sitting there. Right, to get 28, add 23 to both sides, and then undo that multiplication with division. You end up with 28 over 7, 28 divided by 7, which is 4, and so m is 4. Okay? So now you try. You're going to look to simplify first. We're going to sort of slide that into our step-by-step process. Identify the variable that you want to isolate, that you want to get by itself. And then see if you can simplify either side of the equation. Then undo your addition and subtraction, and then undo your multiplication or division. So what did you get? You want to combine these 2 terms first, 11m and negative 6m, which is 5m. And then just bring down your minus 8 because you can't simplify it. Then we'll undo this subtraction by adding 8. 5m equals, and this is 30. And then we're going to divide both sides by 5. And so m is 6. Okay? How about 6? Try that, guys. Stop the video, and we'll show you what you should have done. Okay? Did you get 34 over 7? It's a weird fraction for an answer, but that is indeed the answer. So you wanted to combine the 2k and negative 9k to get negative 7k. And then you just bring down the 4 because you can't simplify it with anything. And then you're ready for your 2 steps. Subtract 4 to undo that addition to get negative 34. And then divide both sides by negative 7. The 2 negatives divide out. And so you get 34 over 7. Okay, good. Now, what about a situation like this? We're still looking to simplify either side of the equation if we can. Nothing to simplify over here, but there is over here. We can distribute that 3. So when we do, 3 times 2 is 6x. 3 times negative 6 is negative 18. Right? And then we're ready to undo our subtraction first. Always have to do that first. And then divide both sides by 6. And so x is 6. Make sense? All right, what about this guy? Simplify each side first, then get into your solving step by step. Try it out, see what you come up with. Okay, you want to distribute here first, so you get negative 16x plus 8 equals 36. Now we're ready to subtract 8 from both sides. Right, and then divide both sides by negative 16. Simplify that down, and you get, what, negative 7 over 4. And then you're good. Okay? One more for you to try. Stop the video, knock it out, and start it back up and see if you're right. And you should have gotten this. Distribute that 5 first, 15p minus 10. Then you're going to add 10 to both sides, divide by 15, and so p ends up being 2. Okay? All right. Now, number 10 introduces some fractions. What are we going to want to do here? Well, your first reaction from what we just talked about might be to try to add those two terms on the left-hand side. Combine your like terms. Those are like terms because they have the same variable, but even though they don't have the same coefficient. So that's okay. But I would suggest that maybe you not do that. How many of you like adding and subtracting fractions, especially when they don't have common denominators? Right, none of you guys do. So don't do that now. We're going to apply a little bit of math magic. And we're going to do that and get rid of those fractions so we don't have to worry about dealing with them. Here's how we do that. Hang in there with that least common denominator idea, right? The least common denominator between 4 and 3 is 12. But we're going to multiply everything by 12 instead of trying to get like denominators and add and subtract those fractions. I'm going to multiply every term by 12. And when I do that, I'm essentially multiplying those fractions. I'm multiplying the numerator by 12 and then dividing the denominator. So we get 12 times 3, which is 36. 36 divided by 4 is 9. Then we get 1 times 12, which is 12, divided by 3, which is 4, so we get minus 4x. Then we get 10 times 12, which is 120. And boom, magically those fractions are gone. We don't have to do that. We don't have to worry about those fractions. Then we can just combine our like terms and get 5x here. Then divide by 5, and we get 24. And so x is 24. So much easier to just clear those fractions. This is called clearing fractions. This is called clearing fractions. Clear them out so we don't have to worry about adding and subtracting them. Okay? Here's one for you to give a shot. See if it makes enough sense. Try it, and I'll walk you through how to do it. Okay, so the least common denominator is 5. I'm going to multiply everything by 5. And I have to multiply every term by 5 to keep this equation balanced. So 5 times 5y is 25y. And then we multiply the numerator. 5 times 3 is 15. Divided by 5 is 3. And then the numerator of the next guy. 5 times 4 is 20. Divided by 5 is 4. Fractions gone. So add 3, add 3. Then divide by 25. And so y is equal to 7 over 25. It does. Okay, another one here. Give it a shot. See what you come up with, and then check your answers by starting the video back up. Did you get 7 over 2 after you reduce your fraction of 21 over 6? I hope you did. Multiply through by 8, and you can kind of see how everything sort of shakes out there. Okay? Clear those fractions. Do not add and subtract fractions. No one likes doing that, so don't do it. Okay? All right. Oh, shoot. Forgot we had one more. Try one more here. Did you get negative 11 over 4? You should have, and you multiplied through by 6 to clear your fractions. Clear them out, guys. Do not keep those fractions. Okay? All right. Story problem here. Martha takes her niece and nephew to a concert. She buys T-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? So, okay, I need a variable first. And what we want to know is the cost of 1 shirt. So X is going to be the cost of 1 shirt. And define my variable there. Now, her total is $67. Where's that total going to come from? Well, it's going to come from what she bought her niece. Her niece got 1 shirt and 4 bumper stickers. Now, we know that bumper stickers are $1 each. So if she bought 4 bumper stickers, then we know we're going to have $4 in there. And her niece wants 1 shirt. And so the cost of the shirt is X. So what she bought her niece is going to be X plus 4. The 4 bumper stickers and then 1 shirt. And then we're going to add into it what her nephew wants. Her nephew wants 2 shirts. So if the shirts cost X, then we have to multiply X by 2 to find out the cost of that. But no bumper stickers. So we don't have to worry about adding any bumper stickers in. So there's your equation. Combine your like terms. Simplify that side of the equation first. Then you're going to subtract 4. And then divide through by 3 to get 21. So what does that mean? Well, that means the cost of 1 shirt is $21. Okay. It's an example of where you might have to do some simplifying even in a story problem. All right? All right. Now, what do we do when there are variables on both sides of the equation? So now we've got to make the distinction. There is a difference between this equation here, 5x plus 2 equals 2x plus 14, and 5x plus 2 plus 2x equals 14. There's a difference. What's the difference? Can you see it? Well, here, the 5x and the 2x, those two like terms are separated by the equal sign. They're on different sides of the equal sign. Over here, the 5x and the 2x are on the same side. And this equation over here on the right-hand side, those are the equations we've been working with. We just combined those and got 7x plus 2, and then subtracted 2 and divided by 7. We don't do that on the left-hand side because they're separated by an equal sign. And I have to keep those equal signs, the sides of those equal signs, balanced. I have to do the same thing to both sides. Right? So what I'm going to do instead is I'm going to move that 2x across the equal sign. And the way I do that is however I have to zero out the 2x. I'm going to zero out the 2x on the right-hand side. And I do that by subtracting 2x. And if I do it on the right-hand side, I've got to do it on the left-hand side. Now my equation is still balanced. I'm still going to have an equivalent equation. That adds to 0, so I just get 14 over here. 5x minus 2x is 3x. And I have my plus 2. And so now I'm back to undoing addition first. and then undoing the multiplication. So x is 4. Okay? And don't worry about the right-hand side. Okay? So move those x's together. You still want to get them together and combine and simplify. But if they're on opposite sides of the equal sign, then we have to zero one of them out. Okay? And also, you may be having to distribute all at the same time. So now we've got a situation where, and I like drawing these lines. It kind of separates the left side and the right side, and we can work with each one individually first. So distribute here first. You get 10x minus 2. Distribute here next, and you get 3x plus 33. Now, I want to get the x's together, but I'm going to have to zero out the 3x. You can do it the other way if you wanted to, but this is the way we tend to do it. And the other way is subtract 10x. But I want to try to keep my coefficient on x positive if I can. It's because it looks nicer. But now I'm ready to just add 2. Divide by 7. And so x is 5. Okay? Now you try. Try this one and see what you come up with. Okay, now what did you do? Did you subtract the 3y? If you did, that's okay. I'm going to add the 2y instead because it doesn't matter which way you move them. Okay? And again, I'm going to try to keep my coefficient positive. So by adding 2y, I know that I'm going to be able to keep that coefficient positive, which is positive 5y. And oh, by the way, keep in mind that when I add 2y to the left-hand side, negative 2y plus 2y add to 0. They don't cancel, they add to 0. And we got to make sure we keep that in mind. Okay? All right, then we're ready to just add 2, add 2. You get 5y equals 10. Then divide by 5, divide by 5. And so y equals 2. Okay? And that's it. Piece of cake, right? Check this guy out. Give it a shot. Start the video back up and see if you're right. And so, did you distribute the 7 and the 3 first? I hope you did. Then did you add the 7a to both sides? I hope you did. That keeps your coefficient positive. You could certainly subtract the 3a from both sides and still be okay. Okay? And then we add 12, divide by 10, and a ends up being 4. Okay? All right. More story problems. Okay? Number 19, the printing place will print business cards for 10 cents each plus a setup charge of $15. The card creator offers business cards for 15 cents each with a setup charge of $10. What number of business cards cost the same from either printer? So first things first, what do we want to know? We want to know the number of business cards. So X is going to be the number of business cards. Now, we want to know when printing place is going to be equal to the card creator. Well, where is the cost? What's the cost of the printing place? Well, there's a setup charge of $15, and they print cards for $10, 10 cents each. Each is that word like per, where you're going to multiply. Okay? So each means I'm going to take the number of cards, x, and multiply it by 0.10, or 0.10x, and then add the 15 to it. Now, the card creator says that they're going to charge $10 for a setup fee, and they're going to charge 15 cents each card. So I know I'm going to take the 15 cents and multiply it by x, because that's the number of cards, and add 10 to that. So I want to solve this equation and find out when the number of cards will make these two costs equal. Okay, so same thing. I'm going to subtract the 10 cents from both sides and get 0.05x plus 10. Then I'm going to subtract 10. Then divide by 0.05. And so x is, so these are going to divide out to 1. X is going to be 100. So it's going to take 100 business cards in order for those two costs to be the same. 99 and one of them will cost more. One of the places will cost more. And 101, the other place will cost more. Okay? All right. Next story problem. Give this a shot. Come up with what you're trying to figure out. Define your variable. Set up your equation and solve it. And then write your answer in a nice, complete sentence. I didn't do that in the last example, but you're going to want to do that here. Stop the video. Give it a shot. And then start it back up and see how you did. Okay, so X is the number of pizzas. How many pizzas does Sally need to sell to break even? Okay, so X is the number of pizzas. That's what we don't know. Now, what does break even mean? Well, she spent $600 on equipment to get the business started. So by the time you take the money she makes off of selling pizzas and subtract off the amount it costs her to make the pizzas, that becomes her profit, right? It becomes how much money she makes off of the pizzas. That needs to be equal to how much she spent on her equipment, the $600. That's where the 12x minus 4x came from, right? 12x is how much she makes off of each pizza. $12 each pizza, so 12 times x. But it costs her $4 to make it. So the 4x is how much it costs her to make the number of pizzas that she needs to make. So we take the amount of money she makes on a pizza and subtract out the cost to get her net profit. So 12x minus 4x equals 600, and then you're going to want to solve. Combine your like terms first, simplify the left-hand side, and then go solve. And so x ends up being 75. She needs to sell 75 pizzas. Okay? All right. Now, infinite / no solution. What happens if we're solving an equation and weird stuff happens, right? This is only going to happen if you have variables on both sides of the equation, like number 21. Now, we know to simplify first. I'm going to distribute the 2 here. And then I know I want to get those x's together, but I have to zero out one of them. I want to zero out this 10x. Right? That's how I get them together, because they're separated by that equal sign. So this becomes 0. And look at that. 10x minus 10x on the left-hand side also. That becomes 0. So I get 12 equals 12. There's no more variable to solve for. The variable went away. It added out to 0. So we get 12 equals 12. Well, what does that mean? Does 12 equal 12? Yeah, of course it does. So what that means is 12 equals 12 all the time. No matter what we plug in for x, 12 will still equal 12. So this is a situation where we get infinitely many solutions. This is what's called an identity, okay? What that means is, in the world of checking your answer, you can plug in any number you want to for x, and this equation will still be true. There will be infinitely many solutions here. Okay? And that's if, when we zero out our variables, if we get two numbers that actually are equal to each other. All right? Number 22. When we simplify and try to solve, something weird happens here as well. Combine those like terms to get 9m. Now, we have a variable on either side of the equal sign, so we have to zero one of them out. So I'm going to subtract 9m here, subtract 9m here. These zero out, so we're left with -4 equals 5. Well, does -4 equal 5? No, it will never equal 5. So no matter what we plug in for m, this still will not be true. Negative 4 will still not equal 5. And so there can be no solutions here. Okay? So if you zero out your variables, all of your variables, and you're left with two numbers equal to each other, and they're not equal, negative 4 does not equal 5, then there can never be a solution. That's no solution. Okay? Solve this one out and see what you come up with. So did you get this? When you distribute the negative 1, then you have to zero out your x. Subtract 2x from both sides. You get 7 equals negative 3. Since they're not equal, this is no solution. Okay? Try this one and see if you come up with infinitely many solutions or no solutions. Okay? So, did you get this? Distribute the 3. Then zero out the 12 b's. So you get negative 6 equals negative 6. Since the sides are the same, so this is infinitely many solutions. Since you get, so what we're saying here is 12b minus 6 here, you can flip-flop this around and get 12b minus 6 here also, right? And so the sides are the same. You don't necessarily have to go zero out the 12b. You could, right? You could subtract the 12b's. They will zero out and you get negative 6 equals negative 6. You're still going to get infinitely many solutions. But when you're solving an equation and you're working that through, if the two sides end up being the exact same, then there's still infinitely many solutions. Okay? All right. Now, since we've added an extra step here in your solving an algebraic proof, we need to talk about how that would look like. Solving an equation, we need to talk about what that's going to look like in an algebraic proof. Okay? So going back to the proofs that we did before, we still have to be given an equation, right? So the first reason in our proof here is still going to be given. Okay? Now, what would we do first? Well, hopefully you're looking at this and you say, well, you're going to combine those like terms and get negative 3x minus 2 equals 1. And that's exactly what we're going to do here. And we're going to call it combine like terms. Okay. Now, hopefully you're sitting there saying, okay, then the next thing we're going to do is in our equation, we're going to add 2 to both sides. And that's using the addition property. Just like we were doing before. Okay. When we go to simplify, we get negative 3x equals 3. And this is us simplifying. So we write simplify. And then we know to solve this, we're going to actually divide by negative 3. And that's by the division property. And then when we do that and simplify, we get negative 1. And then we're done. Okay? Try this one. Stop the video, write it out, and then you can start it back up and see how you did. Okay, that's what your proof should look like right there. So go through that and check your proof. Make sure that your proof looks like this one. And if there are any issues at all, make sure you come find me, and we'll go through it and get you straightened out. Okay? But that's it. Homework's out in Canvas. Make sure you have that done next time.